and I'm a founder of Capable Robot Components. But this talk was actually done while I was CTO of Carnegie Robotics, and I want to acknowledge their contribution to this talk because I did all these slides while I was there. So Carnegie Robotics is a sort of two halves of the company. One half is sensor products. You see on the bottom some of those sensors. There's a 360-degree camera system that they build, active and passive stereo systems. This is a manhole modeling system that's designed to go into active manholes and build high-resolution 3D models of those manholes. The yellow box in the bottom left corner is an inertial navigation system. It uses RTK GPS in development with Swift navigation. And then Carnegie Robotics also does custom system development, 100-pound, 1,000-pound mobile autonomous ground robots in a wide variety of different markets. The robot on the left here is an industrial floor cleaner that was co-developed with Nilfisk, a giant company in the floor cleaning industry, sort of an 800-pound Roomba that cleans hospitals and airports and things like that. The robot in the middle is a project that was done with the US Army to look for mines and improvised explosive devices. So instead of a soldier walking down a road, sweeping a metal detector and a ground penetrating radar, this custom robot was built to do that job with a operator at a remote distance. And this system here is a precision agricultural robot that does fertilization of corn in cornfields when the corn is very tall. So instead of having a tractor with 10 feet of ground clearance driving over the corn, this robot drives between the rows of corn and sprays nitrogen right at the roots of the corn, which is a much more effective way of spreading nitrogen later in the season than with traditional approaches. So a very interesting company that does a wide variety of robotic applications. And in all these systems, we're using 3D sensors to do navigation, obstacle detection, collision, navigation. And that's where most of the data, if not all the data from this talk comes from, is from the development and testing of 3D sensors in these real-world applications. So I'm going to start first with some criteria and definitions, talking about performance criteria and non-performance criteria that matter when you're discussing 3D sensors. And then talk in detail about three different 3D sensor modalities: LiDAR systems, time-of-flight cameras, and stereo, both active and passive stereo. For each of these, I'll show some sample data, also talk about how they work and their general advantages and disadvantages, and then do a deeper dive into sensor testing and edge cases, both qualitatively and quantitatively, in a couple of different applications and test environments that were built at Carnegie Robotics. I'll say up front that I'm not going to cover other forms of 3D sensor technologies like laser triangulation, structured light, or computed tomography. Those sorts of approaches work very well in some environments, but aren't applicable to the kind of autonomous mobile robot that Carnegie Robotics and that my professional background is in. So I don't have great test data to show you and don't have the personal experience about advantages and disadvantages with those technology approaches.